Okay, here are the integrated 2 notes for 5.1.4. We want to continue being able to look at the quadratic functions. But at this point, we're going to now be given a table, and we're going to see if we can create that quadratic function out of this. So first thing I want to do here, actually, I think I want to go to the next slide, and then we'll come back to this one. Just kind of talk about the notion of what it means to be in different forms of a quadratic equation. So the first form that we actually experienced in this chapter so far is the idea of standard form. Talked about this in class, where you'll notice that it is in descending order. So we have the x with the highest exponent comes first, which is definitely going to be an x squared. And then the variable is going to trickle down to be smaller. So the exponent is going to go from an x squared to an x, and then it's going to disappear completely. So all we have is a constant. We did talk about the requirements for a, b, and c in class. One very, very, very important one is that a cannot be equal to 0. If it is, then you get a 0x squared, which means you don't have any x squared at all. So a couple requirements for this. We know about a, b, and c. So a, b, and c are just numbers, real numbers, and we know that a is not equal to 0, because then it wouldn't be a quadratic. But other than that, at this point so far, a, b, and c don't really mean anything special to us. They will in a little bit. But then we also have the next form. And there's going to be a couple, but here's the next one we're going to be focusing on. Now, continuing on with the exact same fashion here, we still have a, but now we've got these other numbers, D, E, F, and G. And this isn't a typical form that we would stick with, but I did want us to be able to look at it. And it's the idea that A, D, E, F, and G are real numbers. And a still can't be 0. That's not allowed. In comparing these two, we can say that if we think about these as just two different forms, and I'll go through and name the other one in just a second, the only thing we know for sure that they have in common is that a value. Now, this second form is called factored form. Factored form, as we know, experienced a little bit back in the previous chapter, where standard form, if you got rid of the y, would be written as a sum, and factored form, if you got rid of the y, would be written as a product. So we know how to transition back and forth between these two forms. It's just that some are a little bit more beneficial when it comes to being able to write an equation from specific types of information. And there is still going to be another form, but these are really the only two that we're focusing on right now. Whenever you're given a table of values, I think we're definitely going to want to use the factored form. Just remember what we did in 5.1.3 was we took something that was equal to 0. So, for example, we took 0 is equal to x squared plus 4x plus 3. This top part would have been written as a sum. You'll notice, though, that it looks a lot like standard form, except for the y. And then we rewrote it, so it was x plus 3 and x plus 1. So we wrote it as a product using what we did previously in the last chapter, which if you look, really looks like factored form. So we know how to go from one form to the next. Now, when we went through and we solved this, we were, again, in the previous notes, we were able to figure out what x was equal to for each of these. So I want to kind of continue along this path and see what would those actually represent on the graph. So x equals -3, x equals -1. Okay, so stuff that we did previously. So I now want to think about going back to this equation that I'm highlighting in orange right now. So my example of 0 is equal to x squared plus 4x plus 3. I want to compare that to the equation of y equals x squared plus 4x plus 3. So I want to see what those have in common. And actually how they're different. So if I take a look at this, I know that the first one on the left-hand side is a single variable. There's no y's in it. Okay. If I were to graph the answers to the one on the left-hand side, so again, this is a single variable, so a couple differences here. So single variable. The answers are going to be x equals some numbers, whatever they may be. We know what they are because we just solved it. I know how to take the right-hand side of this and actually factor it. So take it from a sum to a product. And I know how to use zero product property to solve. Now, I want to go over to the other equation, y equals x squared plus 4x plus 3. You'll notice that the x squared plus 4x plus 3 is consistent in both of them. So I didn't change the right-hand side at all. But I did change the left-hand side. I want to see what that means. So in this equation, I have y. All right, so that's a big difference. This is two variables. But if I compare it to the other one, and then if I had solutions on this, then the solutions on this, if you want to think about them as values that make that equation true, then I would have x's and y's because I've got two variables. Well, I'm going to go back and I'm going to compare. The only difference between these two equations is the fact that the one on the right has a y equals, and then one on the left has a 0 equals. I want you to think about what would happen if you plug in 0 for y. So what are we finding? Or calculating? What are we calculating? When 0 is plugged in for y. Okay, well, let's see. If we plug 0 in for y and we're finding x values, then we're technically finding some number, whatever it is, comma 0. Let's think about what that is on a graph. If I were to take a graph, doesn't have to be fancy, just a plain old nothing special coordinate plane, and I actually plugged in or tried to plot some number, I don't know, let's say 2, comma 0. That would put me over here on the x-axis. Aha. I think if I'm plugging 0 in for y, I'm actually finding x-intercepts. So if I'm finding x-intercepts from factored form, if I plug 0 in for y, I think I can use the x-intercepts to go backwards and try to get to standard form. Yeah, I think we can definitely do that. So it really is kind of like going from a product to going to a sum. All right, well, let's see if we can test it out. So now let's go back to the previous one. I think if I can get the x-intercepts from the table. All right, let's find those. So we know that x-intercepts are some number comma 0. So let's find them. Now keep in mind that with a quadratic, you can have no x-intercepts, as you've experienced from the last couple of days of assignments. You can have one x-intercept, as you've experienced, and you can have no x-intercepts. Well, with no x-intercepts, this whole idea of being able to use factored form is going to be really rough. So hopefully and ideally, we're going to have two x-intercepts, ideally. So if I take a look at this table, remember x-intercept is some number comma 0. So I'm going to go ahead and highlight those in my table. I have this 1 comma 0 and I have 3 comma 0. All right. Once you find the x-intercepts, I'm going to write those as x equals them. So I'm going to try to build backwards on this. So if I have an x-intercept at 1 comma 0, then that means I have x equals 1. This is called a root or a 0. But I think I can also write this as a factor. Now to do that, I want it equal to 0. So I'm going to take this guy and I'm going to just kind of push everybody, so both the x and the 1 on the same side of the equal sign. So I like to have my x positive, you guys know that. So I'm just going to subtract the 1 to the other side. And equals 0, that's important. This is now called a factor. It's on its way to being a factor. And let's do that with the other one also. So I have 3 comma 0, which means x equals 3 is a root or a 0. Let's get the 3 on the same side as the x because I want equals 0. Okay, that's a factor. All right. So what I'm going to do is I'm going to grab the x minus 1 and the x minus 3. And I'm going to start writing this in factored form. So I'm going to take my factor, x minus 1, and my factor, x minus 3. Now, hopefully we recall from the other slide, there's always going to be some a number in front. All right, well, I don't know what it is. So I'm going to put just a placeholder for a right there. Now, if this was finding the x-intercepts, this would be equal to 0. But I'm trying to build the equation, so I'm trying to step my way backwards. So let's turn that 0 now into a y. Keep my a with me because I don't know what that is. X minus 1, x minus 3. Okay, we're on our way. We have to find a though. I don't really know what it is. I know it's not 0, but other than that, I don't really know. So let's go back to the table. Pick any number you want at all from the table, any point at all. It doesn't really even matter. Let's do the 2, -1. Again, any point. Keep in mind that any point on a graph is identified as an x, y. I want you to plug those in for x and y. So the y was -1, so I'm just going to replace all these guys. The x is 2. So everywhere I see an x, I'm going to plug in a 2. And then I'm just going to drop everything else down. So I'm going to drop down the equal sign. I'm going to drop down the a and the parentheses and the -1 and the parentheses and the parentheses and the -3. If you take a look at this, the only thing I don't know is a. This is good. This is going to give me an opportunity to actually figure out what a is. All right, so let's obey order of operations for sure. Carry that a with us. That's our job. We're going to try to solve for it. Okay, 2 minus 1 is 1. 2 minus 3 is -1. All right, let's keep going. Drop the a. Now multiply the -1 and the 1. That looks like -1 to me. Okay. Now the a and the -1 on the right-hand side are being multiplied. You know there's no operation there. So we're going to actually divide by the -1, the number that's inside the parentheses. Oh, this actually comes out pretty nice. If you take a look at the left-hand side, we know that -1 divided by -1 is just 1. On the right-hand side, we have the exact same situation. We have -1 divided by -1. That's also just 1. So the only thing we have left is a. So now that we know that a is equal to 1, we can actually get closer to finish writing this equation. So I'm going to go back up to where I just had the a plugged in. So take a look back at my work. It's only a couple lines up. I just highlighted in yellow. I'm going to plug in that a equals 1. So right next to it, I'm going to do y equals, plug my 1 in there, and then just copy down my x minus 1 and x minus 3. Now, if I'm told to leave it in factored form, I would leave it just like that. But I also want to be able to practice getting it in standard form. So this is my factored form answer. And then to get it in standard form, I'm actually going to multiply it out. So we are taking it from a product and writing it as a sum. So let's go ahead and multiply out the right-hand side. So this is going to be standard form. Well, the beautiful thing about a being 1, we know that multiplying by 1 doesn't do anything. If I take out the boxes, I don't need the diamonds for this because it's already as a product. If I take that out and I multiply these two together, I'm going to get x squared minus 4x plus 3. And that's our answer to the first one. We're going to follow the exact same process on the next one. So why don't you take this moment, see if you can identify the x-intercepts, write them as roots, so just like the previous example, and then see if you can write out the factors that go with it. That's as far as I'm going to go after I pause this. So identify the x-intercepts, then write them as roots, and then try to rewrite them as factors. Okay, so I was able to identify them from the table. Remember, x-intercepts is what we're looking for, so number, comma, 0. Then I'm going to rewrite those as roots. So x equals whatever the x value was at the x-intercept, and then rewrite them as a factor. So just take the number and put it on the same side as x. Okay, now from here, same process. I know that my factors are going to be x plus 1 and x minus 3. There's there's definitely going to be a number out in front. And then since these are x-intercepts, we would have found them by plugging in 0. So we're just trying to back our way up. So let's rewrite that now as a y, drop the a, and the x plus 1 and the x minus 3. Okay, now at this point, go back to the table and choose whichever point you want to use. You just can't use the x-intercepts because they're already being used. So, well, let's do the y-intercept. I love plugging 0 in. Usually makes my life pretty easy. Remember, this point is in x, comma, y. So plug them in for the x's and the y's. All right, so the y is 6, and all the x's are going to be 0. And from there, I'm just going to drop everything else down. Okay, obey order of operations. So we've got 6 equals, carry the a with us. 1 plus 0 is 1, 0 minus 3 is -3. Okay, multiply. 1 times -3 is -3. Now, we have to make sure that we divide because the a, remember this is in factored form, it's all multiplied together. So to get rid of the negative 3, we're going to have to divide, because that negative 3 is currently being multiplied to the a. On the left-hand side, that's going to give me negative 2 equals, and at this point, based off of, you definitely want to divide by what's there, that's going to give us a. All right, so we know what a is equal to now, which means we can plug that in for a. Okay, so we're going to go back up to the equation. So just a couple stages up from where we left off. Find where it was y equals. We hadn't plugged any other numbers in for x or y, and we didn't know what a was yet. Now let's plug it in. So we get y equals the a that we just found, which is negative 2, and then copy down the rest of it. X plus 1, x minus 3. And then this was factored form. And what we want to do is we want to turn this into standard form. So we're going to multiply it out. My recommendation is to multiply out the parentheses first. So if I were to do this, I wouldn't do the negative 2 yet. I would do it at the end. And multiply out the stuff inside. So that would give me x squared minus 2x minus 3. Now, since we're not quite done yet, now distribute the negative 2. So that gives me a negative 2x squared plus 4x plus 6. That is my final answer. So my standard form answer would be 2x squared plus 4x plus 6. And my factored answer would be negative 2 times x plus 1, x minus 3. And then likewise in the previous problem, my standard form answer, y equals x squared minus 4x plus 3. And my factored form answer, y equals 1 times x minus 1 and x minus 3.